Okay, good morning guys. Today we'll learn about rate of change. Okay, the rate of change, I will take some of the question from page 192 as our example. Okay, the first one, air is being pumped into a spherical balloon at rate of 80 centimeter cube per second. So we can write down here as rate of 80 centimeter per second. So we can mention air is being pumped into a spherical balloon at rate 80 centimeter cube per second. Rate of 80 centimeter cube per second means rate of change volume. Rate of change volume, centimeter cube means the volume, respect to second means respect to t or time. And then when we mention about rate of change, we can mention also as a gradient. So it's the same meaning. Gradient of a graph of v against t. Okay, and then we can write down as dv per dt. That means rate of change of v respect to t, or gradient of the graph of v against t, or the derivative v respect to t. Okay, so the meaning of air pumped into a spherical balloon at rate of 80 centimeter cube per second is the rate of change v respect to t, or the gradient of the graph of v against t, or dv per dt. And then they mention the question is, how fast is the radius increasing? How fast is the radius increasing after t second? So here they mention radius increasing after t second. So in another word, we can mention that the question is, what is dr per dt? Or radius increasing means rate of change or rate after t second. So what is the dr per dt? What is the derivative of r respect to t? And it's given that the previous one we have already the dv per dt. So we have dv per dt already. They mentioned dv per dt is 80 centimeter cube per second. And then the question is the dr per dt. So if we have this thing, remember about the chain rule, that when we have dv over dt will be equal to dv is the numerator, so you should write down at first dv per times dt, and you have dr per dt, so it must be here dr, because dt is the equation, the last one dt, so the one that dt must be at the back. You put it like this because this one is dr, so of course here will be dr also. So you will have dv per dt is equal to dv per dr times by dr per dt. So dv per dt is equal to dv per dr times by dr per dt. It's given the dv per dt. The question is the dr per dt. So you should find what is the dr per dt. So the one that we can find, this one is we have already. This one means the derivative of function v respect to r, since we know that the volume of spherical, the formula is 4 per 3 pi r cube. So that means we can find this one, the dv per dr, because we have the function of v and then we have r as the variable, so we can write down dv per dr is equal to 4 per 3. 4 per 3 is constant, pi also constant, so just let it be as 4 per 3 times pi, and then times by 3, move it down, derivative the variable of r cube, so you have 3 times by r square. So that you can simplify, you can cross out this one and this one, then you will have 4 pi r square as the derivative. Okay, and then because At first, we have the dv per dt, which is equal to at, and then we have now is dv per dr. So we can easily to find what is the dr per dt. Just substitute into that equation. So you have at equal to dv per dr, which is 4 pi r square times dr per dt. Then you can find what is the dr per dt. Dr per dt is equal to 80 divided by 4 times pi times r square, or you will have 20 per pi r square. So this one is the answer for dr per dt in terms of r. Okay, so continue with the other question later on. So this one is our basic knowledge of the rate of change.